Okay, so chapter 6 test is on Monday. The big thing is that you are comfortable finding the antiderivative. On the test, there's going to be like a little section where there's 6 of them, where it's just straightforward antiderivative. There is not a number on the bottom or the top. That means you're not doing the fundamental theorem of calculus. You're just finding the antiderivative of the function. First thing to remember, if you have a single x on the bottom, this is going to be a natural log. Here's why. If I rewrote this and I brought that x up, it would be 2 times x to the power of -1. When you find an antiderivative, if I add 1 here, it would be a 0, which would be fine, but then you have to divide, and you can't divide by a 0. This method does not work. So what happens is they gave us a formula that says if you have 1 over x, you can say it's the natural log of the absolute value of x. Because there's a 2 here, we need to bring the 2 out front. I would have 2 out front of 1 over x dx. Now, that's the constant multiple rule, so it's still there, it just gets multiplied in at the end. The 2 gets multiplied into the antiderivative of 1 over x. That is the natural log of the absolute value of x. Remember at the beginning, we talked about how you have to do plus c, because c is a constant. If you find the derivative of a constant, it goes to 0. So we would not have been able to see a constant in our derivative that they gave us. Okay, next one. If you have more than one piece, you just find the antiderivative of each piece. What I would do here, I'm just going to go ahead and go up here so I have more room. This would be 3x squared. If I have the square root of x, easiest way to do that is write it as x to the 1/2 minus 2. Now, if I'm finding the antiderivative, you integrate each individual piece, one piece at a time. If I go to 2 and I add 1, it is a 3. Divide by 3. 3 divided by 3 is 1. It's 1x cubed. Go to the next term. If I add 1, I would actually be adding 2 over 2 because I'm adding a fraction, so you need a common denominator. When you're adding fractions, the denominator stays. 1 plus 2 gets you to 3. If I divide by 3/2, this is like a 1. Well, you can't divide fractions, so I would keep the 1 the same, change divide to multiply, flip 3/2 to 2/3. 1 times 2/3 is 2/3. X has an exponent of 3/2. The -2 does not have a variable, so I say x to the power of 0. Add 1, the exponent is now a 1. Divide by 1, it's -2x. Don't forget plus c. Now, if I were grading a question like this on the test, this would be 2 points. What I do is every single term is half a point. So this would be half a point, this would be half a point, this would be half a point, this would be half a point. So if you were to forget c's, it would be -1/2. Okay, last one like this. If you're doing an antiderivative of an e term, the e term stays exactly the same, even what's in front of it, anything that is connected. Now you find the derivative of the exponent. Derivative of 3x is 3. Divided out front, this would be 2/3 e to the 3x plus c. So the test has 6 just basics like that. Good to go there? Okay, then the next part, what they told us is when we went into story problems, they gave us values so we could find c. Because if you're doing an application, it doesn't really give you an exact answer or even a good answer if you don't have the full equation. What they'll do is give you some information where you can fill in a value for x, set the problem equal to something so you can solve for c. Here's an example. A company's marginal cost function. Marginal means it was a derivative. Okay, it was this formula. X represents the number of units produced every day. The company has a fixed cost. That means a day that it's closed, nothing is produced, they still have $1,000 worth of bills to cover things like insurance, rent, all of those things. Okay, they want us to find c of x. They gave us the derivative, they want us to find the original. That means I'm doing antiderivative. 0.015 x to the power of 2 minus 2x plus 80. Now we say dx indicating that this was a derivative. We're going backwards to find an original. Now from here, we just integrate each piece. If I add 1, the new exponent is 3, you divide it. 0.015 divided by 3 is 0.005 x cubed. Go to the next term. I see x, but it does not have an exponent. I have a 1 on there. Add 1, now it's 2 divided by 2. This would be negative x squared. 80 does not have a variable. That means it's x to the power of 0. Add 1, it's a 1. That makes it 80 x plus c. This is where we would typically stop. But what they're telling us here is x is how many items you produce. If you don't produce anything, it equals 1,000. If I put in a 0 here and a 0 here and a 0 here, all of this would cancel. And what they're telling us is when we fill in a 0, what the solution would be is 1,000. That tells me that c is 1,000. They want us to find the function for the cost. All I do now is replace c with 1,000. The cost function is 0.005 x cubed minus x squared plus 80x plus 1,000. This is a function now that a company could use if they knew how many items they were producing. They could fill that in for x and they would know their costs. That was 6.1. So what we've done so far, that is the first section. Okay, if you're looking back at your notebooks for notebook checks, if you're missing some, those 4 questions should help you out. Okay, 6.2, Riemann sum. Before they had calculus and they had to figure out areas underneath curves, they used what's called a Riemann sum. All that is where we create rectangles, find the area of each rectangle, add them together, and it is an approximate area. Big thing to remember here, it's not exact. That's why we go to the fundamental theorem of calculus in the next section, because it gives us an exact answer. But let's do one Riemann sum. Below, this is a portion of the graph x squared, so it's a portion of a parabola. Use a Riemann sum to approximate the area under the curve from the x values 1 up to 3. So 1 to 3. If it helps you, you could put x's. Don't go to the right of 3, don't go to the left of 1. You want to find the area just between 1 and 3. Use 4 subintervals. That means 4 rectangles. That's what n is. The first thing we need to do then is calculate what's called delta x. Delta x, you take the largest x minus the smallest x, 3 minus 1, divided by the number of rectangles you want to create. 3 minus 1 is 2. 2 divided by 4 is 0.5. Now this tells you the width of every rectangle. If I start with 1, 0.5 later, I would finish one rectangle, start another one. 0.5 later, same thing. I'd finish a rectangle, start another one. So if I go here and I have every 0.5, this is 1, this is 1.5, this is 2, this is 2.5, and 3. I can see I have 1, 2, 3, 4 rectangles. That's what we need. Now you have to look and say, okay, am I using the right endpoint, the left endpoint, or the midpoint? We are doing the left endpoint. So that means when I figure out what this rectangle is, the height is based off of the left side. Delta x1, what is the area of the first rectangle? The width is 0.5. To figure out the height, you take the left value of this rectangle, fill it into the original function, which is x squared. The left side is 1. If I take 1 and I square it, 1 times 1 is 1. 0.5 times 1 is 0.5. Go to the next one. We're going off of the left, so for a visual, that's what it would look like. Delta x2, the 2 because it's the second rectangle. 0.5, the width will always be the same. Now to find the height. The left endpoint is 1.5. Take 1.5 and square it. 1.5 squared is 2.25. The area of a rectangle is length times width. Multiply those two values together. The area of that partition is 1.125. Not done because we have 4 that we have to create. Delta x3, the width is 0.5. We're going from the left endpoint. The left endpoint of the third rectangle is 2. If I fill 2 into the original, 2 squared is 4. 1/2 times 4 is 2. Last one. Delta x4, the length of the rectangle, it's 0.5. We're going from the left endpoint. Left value is 2.5. Take 2.5 and square it. 2.5 squared is, there we go, 6.25. That is what the height is. 0.5 times 6.25 is 3.125. So we created 4 rectangles, calculated the area for each one. Your Riemann sum is when you add all of those together. That's the approximate curve of the total area. When you add, or from 1 to 3, you just add each one up. 0.5 plus 1.125 plus 2 plus 3.125. 6.75. This is area, so it would be units squared. There is one of those on the test. Then 6.3 happened, and they're like, what the heck are y'all doing? This is approximate. Look at all that work. There's something called the fundamental theorem of calculus. It will get you an exact answer, not approximate. All you need to do is be comfortable finding an antiderivative. So step 1, if you see numbers on the bottom and the top, this is called a definite integral. It means at the end you have a numerical value because you are applying the fundamental theorem of calculus. Here are 2 basics. You start off the same. Take each term, find the integral. If I have x, I don't see an exponent, it's a 1. Add 1, it becomes 2. Divide the 2, this is x squared. Minus 4. 4 does not have a variable. That means it's x to the power of 0. Add 1, the exponent is 1, divide it, it's minus 4x plus c. That was 6.1. Now that there's numbers on top and the bottom, we calculate from the lowest number to the highest number. I take the antiderivative, fill in the largest number, fill in the smallest number, and we subtract. If I fill 5 in, 5 squared minus 4 times 5, you would get 5 plus c, minus. If I fill 0 in, this term has a 0, this term has a 0, all I'd have left is c. When you do fundamental theorem of calculus, you'll always have a positive c and a negative c. The positive c and the negative c would cancel. Your answer is 5 units squared. So rather than having to graph it and draw a bunch of rectangles, you can use the fundamental theorem of calculus. Here's another one. Step 1, figure out what the antiderivative is. This is just one term. Add 1, it's a 3. Divide by 3, this is x cubed plus c. That's step 1. We see that we have numbers on top and bottom, so we calculate from 2 to 5. You always fill in the highest value first, then the lowest value, and you subtract. If I fill in a 5, 5 cubed, 5 times 5 times 5 is 125 plus c. If I fill in a 2, 2 times 2 times 2 is 8 plus c. When I distribute the negative, negative would go to the 8, making it a negative 8. Negative goes to the c, making it a negative c. Here again, you'll see every time you should have a positive c and a negative c. Subtract. 125 minus 8, it's 117 units squared. Also part of 6.3. What they did is they gave you visuals. Okay, this is cool, fundamental theorem of calculus, but what you're doing is the same idea as a Riemann sum. You're just doing it more accurately. So if I looked at this and they wanted me to find the area under the curve, you just set up an integral. Antiderivative, what is the lowest x value for that shaded region? 0. What is the highest value? 5. 0 to 5, and I got that from looking on the graph. We're going from 0 to 5. of whatever the graph is that, or whatever the function is that was graphed. It is x squared minus 4x plus 5 dx. We can find this exact area using the fundamental theorem of calculus. Add 1, the exponent is 3, divide by 3. 1/3 x cubed is the first term. Minus 4x. The x does not have an exponent, that means it's a 1. Add 1, the exponent is now 2, divide by 2, making it negative 2x squared. 5 does not have a variable, so it's x to the power of 0. Add 1, the x now has an exponent of 1, divide by 1, it's 5x plus c. From here, we calculated from going from 0 to 5. Fill in a 5, fill in a 0, and you subtract. So this is, again, make sure you're comfortable filling things into a calculator. 1/3 times 5 to the power of 3 minus 2 times 5 squared plus 5 times 5. I got 16 2/3 plus c. Minus, if I fill in a 0 for x, this term has an x, this term has an x, this term has an x, this would all be 0. All we'd have is c. Positive c, negative c cancels. Your answer is 16 2/3 units squared. If you had a decimal answer, that's totally fine as well. If you had like 16.6 repeating, that's fine. Okay, then we went into applications. On the test where there's applications, you are given the formula. Average value, it's 1 over b minus a. We're going from a to b of f of x. So that will be on the test. What they're doing is, rather than saying, okay, what's the total area underneath the curve? They take the total, and what you're doing is dividing it into sections, saying, okay, what is the average for each individual number along the x-axis? So it's the same thing, you just end up multiplying a fraction in at the end. Here, these are the x values. The lowest x value is always a, the largest is b, because on the x-axis it travels left to right, a to b. Out front, I would have 1 over b is 1 minus a is negative 1. 1 over, well, minus a negative, this becomes a plus. 1 plus 1 is 2. That's what's going to go out front. Now what we do is we go ahead and we find the antiderivative of whatever it is that's graphed, your f of x. For us, they're saying, okay, it's 1 minus x dx. Find the antiderivative. 1 does not have a variable. We add x to the power of 0. Add 1, it's a 1, divide by 1. We have just x minus. X has an unwritten exponent of 1. Add 1, now it's 2, divide by 2. So it's 1/2 x squared plus c. We calculate from negative 1 to 1. I go ahead, largest number is positive 1, smallest number is negative 1. We fill it in. So it's the exact same thing with one additional step at the end. If I fill in 1 minus 1/2 times 1 squared, this is 1/2 plus c. Minus, okay, well, what if it's a negative 1/2? Negative 1. Negative 1 minus 1/2 times negative 1 squared. This is negative 1/2. Okay, that's what I got, negative 1/2 plus c. Distribute the negative, 1/2 plus c minus a negative. This is plus 1/2. Negative times a positive is a negative. Positive c, negative c cancels. 1/2 plus 1/2, well, that's 2. So this part, the antiderivative using the fundamental theorem of calculus from negative 1 to 1 of 1 minus x is 2. They want you to find the average. Now you take your solution times 1/2. 1/2 of 2 is 1. So it'd be 1 unit squared. But again, this formula is on the test. You don't have to have it memorized. It's right in the problem. Okay, this was 6-4. 6-5, or no, this is still 6-4. 6-4 talked about consumer and producer surplus. This is when stores either raise prices because holy cow, we're running out of product, or there's a high demand. I can raise the price. People are still going to buy it. That's called a producer surplus. The price is on the top. Consumer surplus is when, let's say, like we talked about scrunchies, all of a sudden scrunchies are super popular, then like a week later, nobody wants scrunchies and they have like hundreds of them. They're gonna drop the price to move them out so the consumers benefit. If you have a producer surplus, the producer's benefiting, this is the price minus the function. You have whatever's on the top minus whatever's on the bottom. Producer, the price they cranked it. So in this situation, X tells you how many of the items that they have. So maybe in this case, we're talking about like a new type of candy bar. So there's a new type of candy bar, and the store owner looks and he's like, whoa, we only got 3 left. We can crank the price up because if people want it, they're gonna buy it. They're gonna be like, well, they're almost gone. So to find what the price is, that's what P stands for. You have to fill how many units you have into your demand equation. That tells you the price. If I fill in a 3, 3 squared is 9. 9 divided by 9 is 1. 1 plus 1 is 2. So that store owner is like, yeah, I only got 3 left. I'm gonna put those candy bars at $2 now. Well, let's figure out how much extra money he's gonna make by doing that. When you're doing your antiderivative, it's 0 to however many items they have. It's possible nobody's going to buy that candy bar. It's possible that he sells out of all 3, so it's 0 to 3. Because the price was upped in order to make more money, you take the price, that's on the top, minus the function. Instead of saying x squared over 9, I am putting 1 over 9 x squared plus 1. Price minus function. Distribute the negative. 2 minus 1/9 x squared. Negative times a positive makes it a -1. Combine like terms. We're going from 0 to 3. I have -1/9 x squared. 2 constants, +2 and a -1. That's a +1 dx. Now all we do is calculate this using the fundamental theorem of calculus, just like the beginning section. Add 1. If I add 1, the exponent is a 3. Well, you can't divide fractions. When I divide by 3, this is really 3 over 1. So I need to realize that what I'm doing is multiplying by the reciprocal. If I take -1 over 9 times 1 over 3, this is -1 over 27 x cubed. 1 is x to the power of 0. If I add 1 and divide by 1, it's 1x plus c. We are going from 0 candy bars to 3 candy bars. You always fill in the largest number first. Back to the calculator. -1 over 27 times 3 to the power of 3 plus 3. I end up with 2 plus c. Minus 0. Well, this term has a 0, this term has a 0, because you would fill it in for x. All I would have remaining is c, positive c, negative c. So when that store owner realized that there were only 3 candy bars left, so he's like, let's go up to $2. All he profited above and beyond what would be normal, he got an extra $2 out of the deal. Producer's surplus. Okay, then we had a section where they said, okay, we have fundamental theorem of calculus, that's awesome. You can find the area from a curve to the x-axis. What if you have 2 curves? If you have 2 curves, we can still find this area. But what you need to do is take the formula from the top curve minus the formula from the bottom. So you look for that region that you're trying to find the area of, and you have to figure out which equation would be on the top to create this and which equation would be on the bottom. We are looking at this region right here. Okay, so I can see that both of these are parabolas. You got to think back to transformations from Algebra 2. in order to have a parabola open downwards, that means it was flipped over the x-axis, meaning you have a negative a value. The parabola on the top is negative x squared plus 2x plus 3 minus, in order to have a parabola open upwards, your a value must be positive. The parabola opening upwards, that's the one where the curve is underneath the area. That is this one right here, x squared minus 4x plus 3. I am subtracting something that has more than one term. This negative applies to every single term of that second group. Negative x squared plus 2x plus 3. Now distribute. Negative x squared, negative goes to the negative, positive 4x, negative goes to the positive, negative 3. Combine your like terms, and for our numbers on the top and the bottom of the integral, what is the smallest x value that we're looking at? We're looking at the shaded region. We're going from 0. The highest x value for the shaded region is 3. Negative x squared and negative x squared makes negative 2x squareds. X's, 2x plus 4x makes 6x. Constants, positive 3, negative 3 cancels. Now it's just the straightforward fundamental theorem of calculus to find the answer. Add 1, we get a 3. This becomes negative 2/3 x cubed. X does not have an exponent, so it's a 1. Add 1, the exponent becomes a 2. Divide by 2, giving us 3x squared plus c. We calculate from 0 to 3. F of 3, f of 0. Fill her in. Negative 2/3 times 3 to the power of 3 plus 3 times 3 squared. I got 9 plus c minus. If I change all of the x's to a 0, this becomes a 0, this becomes a 0. What we have is c. Positive c, negative c. The area between those two curves from the x value 0 to 3 is just 9 units. Okay, these two questions were yesterday, so I was wrapping everything up. Future value is like a what if scenario. What if you put money into, I don't know what they're doing up there. What if you put money into the bank and you make sure that at the end of every year, you yourself have put in the exact same amount? Then they'll give you an interest rate. How many years are you going to do this? Your what if scenario is if you can keep this up. I swear they're like tap dancing. If you could keep this up, what would be the total amount in the account after however many years? Here's the formula, and again, it's on there. 0 to n. 0 is there's a time where you did not have this account. Okay, so it's at the beginning. N is the number of years that you're saving money. K is how many dollars or what is the amount that you are investing every single year. E to the power of R. R is an interest rate. In parentheses, it is N minus T, dt. So again, N is the number of years, R is the interest rate, T is a variable, so we keep it in terms of T, and we know that because of dt. Okay, so I go ahead and look at our what if scenario. Suppose that money is deposited into an account at a steady rate of $2,200 per year. That's what K is. So whoever has this account every single year, they are making sure that they put in exactly $2,200. Okay, the account pays 3% interest compounded continuously. When you see continuously, you know that there's going to be an E. The interest rate is 3%, 0.03. How much money will be in the account if at the end of 6 years? So N, number of years is 6, minus T. We're going from 0 to 6 years. The first thing we want to do is get rid of the parentheses and the exponents. I go ahead and distribute. 2200E, if I take 0.03 times 6, it's 0.18 minus 0.03t dt. Find the antiderivative. Okay, this is an e term. Because it's an e term, I go ahead and keep this exactly the same. Find the derivative of the exponent, negative 0.03, divide it out front, negative 0.03. Calculate this. So I have 2,200 divided by negative 0.03. This is what we get. These problems, you get crazy numbers, so just kind of be forewarned before we jump into it too far. Negative $73,333.33. That's the number up front. Everything else stays the same because it was an e term. E to the 0.18 minus 0.03t plus c. That is your antiderivative. To calculate the total amount of money that would be in that account after 6 years, we have to go from 0 to 6. Fill in a 6, fill in a 0. Negative $73,333.33. E to the power of 0.18 minus 0.03 times 6. And remember from yesterday, what happens is you end up with that number. When you fill in the amount of time, you do get the value that you started with. Okay, that is right. Negative $73,333.33 plus C. Now we change the 6 to a 0. I can hit the up arrow. Go ahead, find out where I have the 6. Change it to a 0. And this will go in the second bracket. Negative $87,795.94 plus C. When I distribute the negative, negative $73,333.33 plus C, minus a negative, this becomes positive $87,795.94. Distribute that negative into the C, so it's minus C. Positive C, negative C, when you add those two numbers, that tells you how much money would be in the account. Negative $73,333.33 plus 87,795.94. The account would have $14,462.61. Now, if this were ever you actually in a scenario, before you did this, because this is a what if, okay, how much money would you have if you could afford to do this for 6 years? I would look and see how much money you made. The only thing you'd be doing is putting in $2,200 per year. If I put in $2,200 per year, and I did that for 6 years, it's costing me $13,200. That's how much I would put in. But at the end, you have $14,462.61. So you can see how much you would make on that and determine, okay, is it worth it to wait over 6 years to make that much money? Okay, last thing, the volume of a solid. So you can take a graph, okay, and you visualize this curve, and if you like spin it around the x-axis, it spins and spins and spins, you get a circular base, and we can figure out the volume of that shape using this formula. It is from A to B. A is the smallest x value that you're using, B is the largest. Pi, the reason why we have pi is because we're rotating it around the x-axis. The base is going to be a circle, okay? So pi is within the problem. Then you take whatever the function was and you square it. So here is an example. Again, this is on the test. You just have to know how to use it. Okay, let's find the volume of a solid of revolution if we were to graph the parabola 2x minus x squared, and you are rotating the portion from 0 to 2 around and around and around and around. Okay, here's how you'd set it up. We're going 0 to 2 pi. What we graphed was 2x minus x squared. We square it dx. The easiest way to do this in terms of pi, do the constant multiple rule. Take pi out front. If you have an exponent on a binomial, what that means is that we have that binomial, we have it 2 times. I have 2x minus x squared twice. Go ahead and multiply them together. 2x times 2x makes 4x squared. 2x times negative x squared, negative 2x cubed.
Please excuse me for this announcement. The 10th graders are just now getting back from the career fair and they are having lunch, so please excuse them for their next hour class. They'll be coming in at about 1:20. Thank you.
Perfect. Negative x squared times 2x would be negative 2x cubed. Negative x squared and a negative x squared is positive x to the power of 4. So pi is out front. We're going from 0 to 2. Combine your like terms. X to the power of 4, negative 2x cubed, negative 2x cubed makes negative 4x cubed plus 4x squared dx. At this point, it is just the fundamental theorem of calculus like we've been doing the entire chapter. The difference is, once you find this value, you take that answer and you multiply it by pi. Add 1, the exponent is 5, divide by 5. 1/5 x to the power of 5. Next one, add 1, the exponent is 4. Divide by 4, so it's minus x to the power of 4. Add 1, now it's a 3. Divide by 3, this is 4/3 x cubed plus c. We are going from 0 to 2. So f of 2 minus f of 0. Plug her on in. 1/5, 2 to the power of 5 minus 2 to the power of 4 plus 4/3, 2 to the power of 3. I ended up with 1 and 1/15 plus c. It's nice when they give you zeros, because if I go ahead and I want to fill in a 0, this is 0, this is 0, this is 0, all I have is c. Positive c cancels negative c, leaving you 1 and 1/15. Take that answer, multiply by pi. So currently, that's what I have in my calculator, 1 and 1/15. If I hit times, it will take the previous answer, so I don't have to re-enter that. Times, here's the pi key. Hit enter, it is approximately 3.35. This is volume, so it would be units cubed. How many units could you fit inside of that shape if you rotated? That is what is on the Chapter 6 test.